Assalamu alaikum. Today our lecture is voltage multiplier. This is the last lecture of chapter 2. In this topic, this is the first half wave voltage doubler. In this topic, what happened? See, there first we use the circuit of a clumper. If you see my last lecture, you are come to know this is the clumper circuit. So when the positive half cycle is passed through this circuit, the capacitor C1 is charged, and when the negative half cycle is passed through it, the D1 is reverse bias. On the other hand, D2 is forward bias. So the capacitor C2 is charged, while C1 is not discharged but add up with negative half cycle, and both negative side of the input wave and this capacitor charging are discharging at C2, which is add up at 2 Vp at a result we get. So when C1 is charged, I again mention you, when C1 is charged at D1 is forward bias for positive half cycle, while the D2 is reverse bias. So the current do not pass into the next loop and pass through this circuit. When positive half cycle is come to an end, negative half cycle is starting, the D1 is reverse bias and D2 is forward bias. Then D2 is as a forward bias, the current pass through in such a way, and as C1 is not discharged, so it add up to the C2 capacitor at raised to the 2p value, and V voltage across C2 is add up with voltage across input voltage of Vp and voltage of capacitor C1, both add up at capacitor C2, and we get the output voltage at 2p Vp as it mentioned it. You can see it as we add the voltage at C1 at Vc1 is equal to Vp. So if we put this value in this equation, we get 2 Vp. This is the half wave voltage multiplier. Now full wave voltage multiplier. In full wave voltage doubler, see, when positive half cycle is going, D1 is forward bias and current stored at capacitor C1 equal to the Vp. On the other hand, D2 is reverse bias. When negative half cycle, D2 is forward bias and D1 is reverse bias. And again capacitor store in C2 is Vp. We get the output across this point and this point, which is equal to 2V, because C1 is not discharged. both capacitors are discharged at output, and which is equal to 2 Vp. Next, voltage tripler. What happens when positive half cycle is going on? Vp C1 charge at Vp due to D1 is forward bias. Next cycle is going for is passing through the circuit, and D1 is reverse bias and D2 is forward bias. So this Vp is charge the capacitor at 2 Vp, while this charge the capacitor at 2 Vp. So on the third wave passing through the circuit, D3 is forward bias and voltage is again very high, and this capacitor discharge at and charge this capacitor at 2 Vp. So when we get the output voltage across these terminals, we get 3 Vp or waveforms. Voltage quadruple. In this form, same situation occurs, but we charge another capacitor C4 at 2 Vp due to D4, and for this capacitor we get the output voltage across these points is equal to 4 Vps. There is chapter ended. Now you can review these chapters. This is the review of all the topic of chapter 2. I discuss only the diagrams. You can read it by yourself. Like that. When we test that diode in forward bias, then it gives you 0.7 volt, and we set up the meter in that form, or using we testing the diode. On the other hand, when we use a diode by this, it acts as a open circuit or no voltage passing through this diode. On the other hand, if it is shorted, there is also 0 volt, which shows that in reverse bias there is also 0 volt, which shows that the diode is not correct. There it shows that when we give the oscilloscope to the power supply, it gives the value, or it gives the result like that. If it gives the ripple, this is not a correct DC power supply. There we get every step by step the oscilloscope result. When TP1 means step down transformer we use the full wave rectifiers, we get the pulsating DC. Then we use the capacitor filter circuit, capacitor input filter, but it do not filter it, which is incorrect, as it mention it. There it can also there show that it is not corrected. I mentioned you what happened. This is the result of a filter circuit. It mentioned it. This form is show that both of oscilloscope results, and there it gives the pulsating DC of the capacitors. This is the ripples of a filter circuit result, and this is pure DC. On the other hand, is shorter filter circuit capacitor, and this is the waveform when the full wave rectifier is passing through it. Then we get the result is, then if we apply the filter circuit, then we get this result. We use also a surge resistance for the surge current not backward, go to the backward. These are all data sheets. No, this is the full wave rectifiers. These are the ripples. These are the mainly mentioned by the ripples of the ripple circuits. You can see it on the oscilloscopes. Very small because the voltage is very high. You can see it there is also mentioned. Again, the full wave rectifier ripples at very high voltage, at very high in large value of a capacitor, at very large value of capacitors, and there the half wave rectifiers. Okay, thank you. I think it it is completed the chapter now. Mm, yes, thank you. You can read it and by yourself and complete it. Next we use Next we start the chapter third by Xenodiode or special purpose diode. Okay.